All right, for number 12, we have calculate the mass of potassium chlorate that would be required to produce 29.5 liters of oxygen, measured at 127 degrees Celsius and 760 millimeters of mercury. So a couple of things that would catch my attention. First, if I need to know the mass, I would need to know the moles. After unit in temperature, it's Celsius, so that means I have to change it to Kelvin. So that would be, we'll add 273, that would be a total of 400 K. The pressure is not in ATM, so they're very nice to put 760 millimeters of mercury, so I can have 1 ATM. So pressure is 1 ATM, temperature is 400 K, volume is 29.5. And now we are not collecting this over water, so we don't have anything to consider, like about subtraction from barometric pressure and whatnot. So this is simply a PV-nRT. Yeah, so you find out the N from PV-nRT. So you have 1 ATM times 29.5 liters. You don't know what the mole is, but you can find out in a moment. Okay, ATM liters over mole K, and then the temperature is 400 K. So moles is equal to 29.5 divided by 0.0821, and then also divide by 400. Now, when you divide, one thing I must remind you is that if you are going to divide all the things together in one single step, then you must make sure that you put another pair of parentheses around these two numbers. If not, your calculator would not interpret the thing that you wanted to interpret. So this is the number of moles of what? This is the number of moles of oxygen. Now, this is another thing. If you don't label, you probably will think that this is the moles of potassium chlorate. Yes. 1.1. 29.5 divided by 0.0821 divided by 400. It's 0.898. Tell me what you type in the calculator. Divided by, ooh, no. You were solving for N. You divide this over. Okay. And then what else? Well, that's the moles of O2, and then we need to have the chemical formula so that we know the mole ratio. So chlorate. Okay, so now you have 0.898 moles of O2 times 3 moles of O2 to 2 moles of KClO3, and then you go to molar mass of KClO3 to whatever the molar mass is. That will be about 123.5 grams of KClO3. So 123.5. So that should give us approximately 73.9 grams. So so probably some rounding. So therefore, the answer would be 73.4 grams. Again, gotta know where are the the potholes. If you are rushing and you are not labeling, it is extremely easy to treat the moles that you find over here, and you just wrongfully assume that this is the moles of potassium chlorate. And always tell students this. Always tell students that use gas laws for gases. Potassium chlorate is a solid. It's not a gas. Okay, so you find out the moles of you find out the volume of the mole of the O2 gas, and then you just convert it, or just use stoichiometry to find out the moles of potassium chlorate and then the mass of potassium chlorate.